So we're going to be writing functions given a table of values, and we've done something extremely similar when we graphed lines making a table. Here we have an equation, y equals x plus 1. If we want to make an xy table, let's say our x value is, well, how about 1? If our x equals 1, then we could plug that in here and we'd get y equals 1 plus 1, or y equals 2. If we plugged in x equals 2, we'd get y equals 2 plus 1, or 3. And you could continue to do this to make your table of values. If we use 3, we'll get y equals 3 plus 1, or 4. And we'd get a whole table that represents all the points that we can make using this x and y. Let's go ahead and take this xy table and convert it to an x f of x table. When you think of functions, I want you to think of f of x as your y value. So this xy table is the same as an x f of x table. We see we have the point 1, 2, we have the point 2, 3, we have the point 3, 4. And what you might notice is that each one of these is just adding 1 to the x value to give you your f of x value. So if we wanted to write a function to represent this x and f of x table, it would just be f of x equals x plus 1, since our f of x value or y value is just adding 1 to these x values. That's what we do up here. F of x equals x plus 1. And this y in function notation is just written as an f of x. So this is what we're going to be doing with these. We want to try to write each relation as a function using f of x notation. So first, look at our x and f of x table. Our first point is negative 2, negative 4. I notice that negative 2 minus 2 is negative 4. Next, we have negative 3, negative 5. Negative 3 minus 2 is negative 5. And then we have another point, negative 10, negative 12. And negative 10 minus 2 is negative 12. So our function can be written as f of x equals x minus 2, because each of our x values subtracting 2 will give us our f of x values. So this is going to be our function. Here we've got another x f of x table. Our first point is negative 2, negative 6. Well, I can see that negative 2 minus 4 is going to be negative 6. So that works. Here we have negative 1 to negative 3. Well, negative 1 minus 2 is negative 3. Now, check this out. This is not consistent. Whenever you have an x f of x table, this has to give you the same difference or pattern for each value. Since those were not the same, we know our function is not going to be using subtraction. Okay, is there anything else we can use to get negative 2 to negative 6? Well, we can't add, we can't subtract. What if we tried multiplying? Negative 2 times 3 would be negative 6. Then we have negative 1 times 3 would be negative 3. 0 times 3 is 0. 1 times 3 is 3. And 3 times 3 is 9. Perfect. Each of these values are the same, and it's just multiplying by 3. So our function is going to be f of x equals 3 times x. And there we go. So when you're attempting to write functions to represent these tables, it's kind of like a puzzle. What operations do you have to use to get from your x to your f of x? And it has to be consistent the whole way. Now you can use any type of operations to get this done. Here's what we're going to be focusing on: addition, subtraction, multiplication, division, or a combination of those. So if your first attempt at adding doesn't work, you might try multiplication or division, etc., etc. Let's try one more and I'll send you on your way. Here's our first point, negative 3, negative 7. Well, okay, negative 3 minus 4 would be negative 7. But 0 minus 4 is definitely not negative 1, so that's not it. All right, I might try multiplication. Well, negative 3 times 2 is negative 6, but that's not negative 7, okay? And it doesn't look like we can multiply. It doesn't look like there's any consistent pattern with division, right? 0 divided or multiplied can't give us negative 1. Okay, so it looks like we might have some sort of combination with these. So to test this out, let's go ahead and see what happens when we multiply negative 3 times 2. Doing that, negative 3 times 2 is going to be negative 6. If I subtract 1 from negative 6, that's going to give me negative 7, which is what I want. Okay, let's try that pattern. That's going to be a pattern of 2 times x minus 1, or 2 times negative 3 minus 1. Let's try that same pattern with this. That's going to be 2 times 0 minus 1. Well, 2 times 0 is 0, minus 1 is negative 1, which is exactly what we want. Perfect. Let's try with this 1. That's going to be 2 times 1 minus 1. 2 times 1 is 2, minus 1 equals 1. All right, yes, let's just check one more just to be sure. That's going to be 2 times 5 minus 1. Well, 2 times 5 is 10, minus 1 is 9, and it looks like we've got the pattern. 2 times x minus 1. Putting that in function notation, we have f of x equals 2x minus 1. Now, it might not always be simple or obvious what your function operations are going to be, but you might just have to do some guessing and checking until you can find it. It's kind of fun. At least I think so. All right, good luck.